Okay, bit of a short one, expanding binomials. There's only a few little tricks that people usually get tripped up with on this, so this should be a pretty easy one. But as always, we'll try to start with something really simple, just to make sure that our line of logic works. So, in here I've got a bracket multiplying another bracket. That's the basic gist of what our binomials are going to be. Cool, so here I've just got a whole bunch of just standard numbers, so I should be able to run BODMAS stuff, in which case I should do what's inside the bracket first. So we've got, oh well, that's going to be a 5, that's going to be a 9, and together we get 45. Nice, boring. Okay, well, what if I've got something like this? Well, now I can't do the brackets first because I don't know what the x's are. So, what we need to think about is, okay, this 5 times by that 9. Well, if I think about this, that's just saying, okay, I could just as easily have said, oh, there are 5 lots of 4 and 5 lots of 5. So really this 5 is multiplying each of these individually, and then we're adding the result afterwards. Okay, well that's fine. Well, that's just like expanding brackets as we did previously. If we've got 2 things over here, what's that doing? Well, just like we said this is 5 times 4 and 5 times 5, this is simultaneously saying this is 2 times 5 and 2 times, 2 times 4 and 2 times 5, and also 3 times 4 and 3 times 5. Alright, well there's a bit of stuff going on there, so maybe we could shorten that a little bit. So, here's where we get our rainbows. Oops, mixing my red, there we go. Cool. So, I'm going to do red first, okay. 2 by 4, that gives me 8. Okie dokie. 2 by 5 gives me 10. That's a positive 10, by the way. Okay. 3 by 4 is 12. 3 by 5, 15. Beautiful, and if we add all these together, hopefully, what do we get? 10, 20, 30, another 40, 5. Beautiful, so we got the exact same result as we did last time. That's handy. Cool, so I've got all these coloured lines going everywhere. One way that some people remember is to say FOIL, which I don't particularly subscribe to, but I'm doing it in the background anyway, I suppose. So, this is saying the first, so that means the first out of both, so that's red. Actually, I should have done this in colour. Oops. So, that's first. Cool, okay, next colour was green. That's saying the outermost. Outer, and since I'm spelling down the page, I'm hoping I'm spelling that right. Excuse me. That's the outer 2. Next was blue, which was inner, so the inner 2. And then L for the last 2. So the last is the 3 and the 5. So that's what that stands for. Doesn't particularly matter if you run FOIL or not. All that matters is you've managed to pick every pair possible. So 2 with 4, 2 with 5, 3 with 4, 3 with 5. We're not doing 2 with 3 and 4 with 5 because they're not multiplying, they're adding. So it's just every multiplicative pair. Cool. Okay, well, we've got a whole lot of stuff going on with this next guy. Let's try to use this. So, first one. First and first, x by x is x squared. Beautiful. Next one. Outer 2, x by 4, well that's 4x. You could write x4, but usually you put your numbers first. Cool. 3 by x, that's 3x. And last, 3 by 4 gives me 12. Okay. And then we add them together, but this time, oh hang on, x squared, there's no like terms for x squared. Okay, that's fine. We'll just go, alright, x squared sits. 4x and 3x, those are like terms, so we can add those. Pure 12, well, he's just going to sit pretty. And there we go, that gets that. And that's basically it. Now, there's just a couple of little complications that can appear, so let's try to do some of them. With this, I've got 3x multiplying by 5x. So, okay, that's 15x squared. 3x and negative 6 gives me negative 18x. 4 and 5x gives me 20x. And 24. Cool. 4 and negative 6 gives me negative 24. Cool. And always try to collect your like terms. That's the only x squared, so he sits pretty. These two will they're like terms, so negative 18 plus 20 gives me plus 2, lots of x, and negative 24, just a pure number, sits pretty. Beautiful. Okay, well, here we don't even have any numbers, can still run the exact same thinking. So, first by first gives me x squared, out of 2, x by negative b is negative bx, oops. A by x gives me ax, and a by negative b gives me negative ab. Okie dokie, and then we're going to try to simplify whatever we can. Okay, well, none of these look like terms. Well, there's one thing that you can do. You can leave it like that, and that's perfectly fine in this case. You may see answers turn into that as well though. So all they've done is they've taken out a common factor of x for this bit. So I've got ax's minus bx's. So that's all that's doing. This isn't inherently better than that one per se, because you've still got something that's essentially the same length. That doesn't make it particularly better. But commonly that's how it'll be written. Cool, okay, over the other side. Alright, this thing all squared. Oh, well, that's a bit weird. Please do not say that this is x squared plus 9. That's a very, 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 very common error. Even for kids that have been doing proper algebra for some time, they can do calculus and then they forget to expand this properly. So, I highly, highly recommend that whenever you have some bracket squared, until you are like absolutely perfect at it, it's usually a good idea just to rewrite it as such, because then that tends to remind you, oh yeah, we've got to do the rainbows. So that's x squared, that's 3x, there's another 3x, and 3 by 3 is 9, cool, and then collect like terms as always. Beautiful. Okay. Well, what if we've got something a bit chunkier? Same thing, whenever you have some bracketed term squared, highly recommend, particularly when things aren't so trivial, that you write out exactly what you're doing. I'm doing this multiplied by itself. Cool. Rainbow time. Ax by ax, that's a squared x squared. Ax by negative by, so a positive and a negative gives me a negative. A times b times x times y. It's usually a good idea to put them in alphabetical order. Cool. These two, negative by a positive, negative a by b by x by y. And people. Negative by negative is positive, b times b squared, y times y squared. Beautiful. Cool. Alright, we've got a squared, x squared. These are the same thing, so I've got negative 2 of a, b, x, y's, and plus b squared, y squared. Beautiful. So that's that done. The other things that can happen, you can have the whole thing getting multiplied by a 4. So you can choose to do it one of two ways. You can either put that 4 in there straight away, in which case you've got 4x plus 8. So it's either 1, 2. And then multiply that by negative 6. So you could do it that way. Or you can expand these and then multiply that result by 4. So loops, we get 4x squared minus 24x, add 8x minus 48. Getting a bit too late. Need my brain to work. Okay, so we've got that. And simplify gives me negative 16x minus 48. Cool. Or, alternately, we could have done these two first and then multiplied by 4. So I'll keep a 4 out the front. I'm going to put square brackets just to make sure, just to make it clear that it's a different idea. So I'm thinking of brackets around this. Cool, expand this, I get x squared, negative 6x, positive 2x, minus 12. Cool, alright, that gives me 4, x squared, minus 4x, minus 12. Everything cops the 4. 4x squared, minus 16x, minus 48. And lo and behold, they're exactly the same, so that's nice. If they weren't the same, they would definitely be in trouble. Cool. Similar story. In this case, I'm going to leave this out the front, like we did on this one. You don't have to, you're welcome to do it whichever way you want. You can do it these times each other, then times by the -5, or you can smuggle this -5 into here now, or you could even smuggle it into that one. You could smuggle the -5 into this and the x into that if you want. Whole bunch of different ways, because a times b times c times d is the same as any other arrangement, so you can pick whatever arrangement you want. Cool, okay. This guy times this guy gives me 8x squared, this guy times this guy, negative 12x, this guy times this guy, plus 12x, this guy times this guy, negative 18, so we've got negative 5x, 8x squared minus 18, negative 5 times these, so I've got negative 40x cubed, negative negative positive, 90x. Done. Cool. Notice that in this case, by doing these first, I actually managed to get rid of a term, so that makes this part easier. So that's usually the better way to go, but having said that, sometimes these numbers will be absolutely disastrous. So if you've got fractions in here, and say they're all over 4, and this is 4 times something, or a multiple of 4, then you're going to want to distribute that first, because it gets rid of some nasty fractions for you. So that's that. It's not the hardest thing in the world, it's just something that commonly slips people's minds, so just wanted to point it out. Cool, cheerio.